Okay, we kind of have already been able, you guys ready? We have already introduced the unit circle a little bit last time, and now we're going to go a little more in depth into it, okay? Back in the day when I learned unit circles, we would draw a circle, and we noted all the points that it intersected the arc at 30 degrees, 60 degrees, 45 degrees, and so forth, and then we memorize the ordered pairs. And I have found that unit circle does not make any sense to why we even do that. And so now we've switched to kind of doing trig around the unit circle and generating the triangle within the angle we want to go to, okay? So that's what we want to get good at, is just generating those angles. Before I forget, let me pause the video. Before I forget, okay. So I'll publish the extra credit in my prep period today. And so those of you who want to see it during flex, actually I'll try to have it for flex, but for sure then. Okay. All right. I want to.
You know when the ACT is?
Sorry? Tuesday the 11th. So not next Tuesday, the next. So, okay, the video does pick up on little conversations, so do your best to try to be, aware here, and then we'll get going, okay? All right, you guys, when you set up your unit, your angles along the unit circle, and we've already kind of done some problems, like, hey, sine of theta is blank, okay? This opposite over hypotenuse, I kind of want to have you guys see it based on x and y directions and coordinates of because these, when you rotate, this terminal side can be considered always going through some point. And we'll call that point just xy for easy right now, okay, for easy stuff right now. So wherever xy is, notice how this leg is the x direction on the x-axis, on the coordinate plane. And then this vertical leg is the y direction. And that's where your ordered pair is on the point that they go through. And then the radius is always this hypotenuse of this little triangle we get to form when we're using unit circle rotation. So when you guys, from theta, which is always your reference angle, so even though theta is this, from theta prime, we always use the reference angle for this, because you know how I told you we use triangles to do SOHCAHTOA. And now we're asking you guys to be able to do trig on any degree possible, right? Well, that's impossible, so we use reference angles to create our triangles, okay? So from the reference angle, adjacent is always going to be the x direction, no matter where the reference angle is. Like, let me do one that's in the quadrant 4. So adjacent, again, is always the x direction. From this reference angle, your opposite is always the y direction. And then your radius of this unit circle is always your hypotenuse. So when we are going to be picking out angles later and trying to set up what the ratios are, you guys can view this as, sine of an angle was opposite over hypotenuse. That's what we were used to. It's the y over the r. It's the y direction over the r. Now the benefit to knowing this will come because we're going to be doing quadrantal angles. I haven't taught you guys yet how to do a quadrantal angle on the x and y axis. And so this knowledge is really helpful, okay? So a cosine used to be adjacent over hypotenuse, but your adjacent is always going to be the x coordinate of whatever the point is that you're going through. And then your tangent, remember how it was opposite over adjacent? And so you guys can view the opposites and adjacents as x's and y's if you prefer. Like I said, this doesn't really benefit you unless you are confused on the quadrantal angles the way I teach you. I'm going to teach you how to draw a fake triangle, but if the fake triangle confuses you, you guys can use y's and x's and r's, which I'll get to that. Sound good? So it's just like SOHCAHTOA. That's pretty much what this is for general angles. Oops, I'm not sure. Sorry, it's hard to multitask in my brain sometimes. SOHCAHTOA. Okay. Ugh. Okay. So that's all this is. All right, I'm going to add another element here. This is something that kind of got you guys, and I said that last question you were technically wrong today. Are you guys noticing? Let's think about this way. If we are doing, if we're in quadrant 1 from this, my y direction and x direction are both positive, and your radius is always positive. And so no matter what the angle is in quadrant 1, every single trig function, all of them end up positive, right? Right? Sine of whatever, cosine of whatever, they all ended up positive. Now, if I move to this quadrant, and so from my reference angle, which coordinate or direction is positive and which one's negative? What's this direction, positive or negative? Negative. But the y direction is positive, and then your radius will always be positive. Well, let's think of this in regards to SOHCAHTOA, or the y over x. So if I do sine, it's opposite over hypotenuse. So that result will be positive, right? But what will cosine be? Negative. And then what will tangent be? Negative. So if you look at all these trig ratios, your only one that was positive were your sine ones. So that quadrant only sine was positive. In quadrant 3, let's drop my reference angle here, okay? Both directions are negative, and then my radius is always positive. So let's do sine, opposite over hypotenuse, negative, right? Let's do cosine, adjacent over hypotenuse, negative. Tangent, opposite over adjacent, negative over negative makes it positive. So if you notice, only tangent and cotangent would end up positive in that quadrant. And then in this quadrant, when I do all of my trig ratios, which one's negative now? The y direction, right? And then your radius is always positive. Sine of this would be negative. Whoopsie. Adjacent would be what? Positive. Good. Adjacent over hypotenuse is positive. So notice how your cosine is the only thing that ends up being positive here.
So quadrant 1 is all of them.
They're all positive. Sines are positive there. So if we would have realized, hey, this cosine, anyway, cosines are negative in this quadrant. And it helps you also with what quadrant you end up in, because I can get cosine to be negative here or here. So when we're going to be picking out angles in a little bit, I'm going to tell you where we're restricted to. It'll help you with what quadrant you're in. Anyway, I have a little acronym. We say all students take calculus, which they don't, but that's our little acronym to know which quadrants which one ends up being positive. All of them are positive, just sines are positive, just tangents, and then just cosines. Not a huge deal, because we can work ourselves out if we're labeling stuff with negatives properly. You don't need to remember this, but if you forget to put negatives where you should, you probably need to remember this, and I'll talk about that in just one moment too. Okay, so here is what you guys are expected. This is the gist of this entire assignment, even though I have a few more questions to talk about. The gist of it is, can you guys find the exact value? When we say exact value, we technically don't want a graphing calculator or a calculator answer, because some of them are going to have radicals. And we also will expect you guys to be able to do stuff on the non-calculator side. So please don't use your calculator as a crutch, okay? If you luck out and it's a nice whole number, good for you. But if it's a decimal, you better figure out what the radical is, okay? So we want you guys to take any angle, whether it's in degrees or radians, and we want you guys to be able to take any trig function of it. Any of it, okay? So if we were to, sorry, I wanted to check one thing. Oh yeah, I have a page. I was like, I have quadrantal angles, they're right there. Okay, so let's try this out. Can you guys find the sine of negative 45? And all of these ones we're going to ask you to do will be specials. Okay, so let's go ahead and draw what the sine of negative 45 should be. By the way, what quadrant will negative 45 drop us in? Quadrant 4. So in regards to, I know that this is going to be a 45-degree reference angle. So in regards to recognizing that all students take calculus, will the sine ratio be positive or negative in that quadrant? Negative. Yes. Remember that, because we might forget to label this negative. And if you don't label it negative, you'll forget. Okay, so let me show you what I mean. So Okay, so since this is a special, where do I put what numbers do I put on the outside? This is a special.
3, 4, 5, something like that.
Specials are either
Oh,
1,
yeah,
root 2. Good. So where does the root 2 go? It's the what? It's the hypotenuse, which is the radius of our little unit circle if I'm rotating, right? And then we have a 1 and a 1. See how easy it is to forget the negative? Do you guys agree?
Yeah.
It's really easy to forget the negative. Where should I put the negative?
That one.
Right here.
Yeah.
It's so easy to forget. So either you need to remember all students take calculus and that this should be negative, or you've got to remember the negative sign. Sound good to everybody? One way or another, you'll be off by a negative. And it's a small deduction on the test. Because on the test, I'm like, ooh, they drew it in the right quadrant. Ooh, they set the sides properly. Oh, they did the right ratio. It's just off by a negative. So it's a small deduction. But it's still something that you are capable of getting 100% on. Okay, what would you guys say the sign of 45 was?
It's like
Opposite over, yep, -1 over radical 2. And I'm fine with this answer, but what's the rationalized answer look like? If I times by root 2 over root 2, what's the rationalized answer?
2 over.
And negative root 2 over just 2. Yep. So you could have, this is the, technically the more simplified answer. Do we feel okay? Let's do one that's in radians. Does that sound good?
Let's do it.
So the radians is what throws my students off the most, and these will be on the calculator side. The reason these are going to be on the calculator side, and we'll usually ask ones that have radicals, so you still have to do it by hand, but it's on the calculator side for those of you who want to convert the degree to the radian to a degree. So those of you who want to convert this, go ahead. Those of you who have it down, what quadrant does 7 pi 6 put us in? Third. Yeah. Who said that? Sky. Explain it.
Because a 180 is 6 of them, so like that brings you to
Good. 6 pi 6 takes care of 6 of them and it gets us to 180. Good. And then she goes one more. So we're going to go like this and we're going to be in quadrant 3.
Oh.
What's this little reference angle? I had how many more pi 6 to get to that? I went from 6 pi 6 to 7 pi 6. So what's my reference angle?
30.
Pi 6. 30. So I'm going to say pi 6 or I'm going to say 30 just so we're all on the same page. We have just now
Wait, how do we know
drawn
it's
our
30?
angle. What's that?
How do we know it's 30?
Because we just went, so we went 6 pi 6 and then one more pi 6.
Oh, because it's
And pi 6 are 30s.
Okay,
Good.
okay. That makes
So
sense.
since we know it's a 30, let me draw this in red. Let's generate our triangle. Cool? All right, now let's go ahead and label the sides. So let's do the all students take calculus. So secant is the reciprocal of which one? It's cosine's reciprocal, right? So should cosines be positive or negative in this quadrant?
Let's go with negative here.
It's going to be negative.
Yeah.
Or just remember your sides. Okay, let's set up our sides. What number should go across from the 30? 1. What should go across from the 60?
2.
Nope.
Right.
Root 3. And then what should be the hypotenuse?
2.
Very good. And then which of these are negatives?
It's the
Wait, wait,
it's
the
the negative one.
negative 3
And 3.
And 3.
Because you're in the negative x direction and the negative y direction. Okay? Now let's do the cosine of it, which was, what's cosine of this? Negative, we're adjacent here. So negative root 3 over 2. So the secant will be 2 over negative, and this could just be negative. And there's our answer, is the negative 2 over
That's
root
it.
3.
There's gonna be.
And you can rationalize it. So the rationalized version of this is a negative 2 root 3 over 3. And those of you who want a bonus point to rationalize everything, do it. But those of you who at least don't want to be deducted 1 point, rationalize at least one time on the test. Okay? All right, let's do one more. That's an angle, and then I have special quadrantal angles, and you guys pretty much have it, but we do have to be able to pick out angles next. So, all right, where does negative 135 put us?
Oh, third.
Quadrant 3 again. If I rotate from my initial side and I rotate here, and I know I'm in quadrant 3, what's my reference angle? And where do I draw my reference angle? And I'm out of space on my slide. Sorry about that. Where's my reference angle drawn again? Is it here or here with the x-axis?
Oh, where you're pointing right now.
X-axis, good. And then what's
Because
the
it's negative, it starts going counterclockwise.
Correct.
Or clockwise.
clockwise is negative? Yep.
Okay.
And then what is our reference angle? How do I
45.
find? Why did you say that?
45.
Yeah.
That's what's
45 plus 45 plus 45 equals 35. 1 is 35.
Yep, so you that's how you visualize it. Another way is I'm just shy of getting 180, so I can do 180 minus 135, right? So this is a 45-degree angle, and so when we set up our little triangle here with our reference angle, what are our sides? What are the legs that are x and the y?
Oh, it's like 1 and 1 and
Yep,
1.
negative 1 though, and
Negative 1,
negative 1. Since all
Square root
students
two.
take calculus, is this going to be a positive ratio or a negative ratio when you're done?
Negative.
Positive, because tangents
Are positive.
are positive in quadrant 3, okay? All right, let's do it. What is the tangent of this?
So crazy.
Oh, it's negative
1 over 1.
Negative 1 over negative 1, which was a positive 1.
Nice.
Okay, the
Yo.
next slide, I want to show you what happens here. So where does 270 drop me? Where is that on my unit circle?
Right in the
It's right on the axis, and we haven't talked about that yet. And so when we go like this, we haven't really done any special stuff with a one that lands on the quadrant or on the axes. And these are called quadrantal angles because they share two different quadrants, like quadrant 1, quadrant 2. They share two different. So it's a little tricky because it's not as easy as us just setting up a triangle, right? So I'm going to teach you a strategy on how to do that. And again, what a quadrantal angle is are ones that lie on the x or y axis. So for easy numbers, this is 0 degrees, and we're going to say that they go through a point, and this is where I told you guys your x's and y's will come in handy, okay? So your x direction, you imagine this initial N-terminal side in here, okay? And they go through some coordinate point. And this is usually a 1. When we generate it ourselves, we use 1 because it's easy numbers. But sometimes we'll have it be like a 4. And that means your x direction and your radius are the same numbers, okay? And again, this will come, so don't panic yet, okay? When it's on the y-axis, it's now at 0, and then whatever your radius is of your circle, it's the y coordinate, okay? If it rotates 180 degrees or pi, it's now at negative whatever the radius of your circle is. And so it's a negative x coordinate, 0. And then if it rotates 270, the one we just skipped,
0.
it's a 0, but it's a negative, right?
Negative y.
So it's going to be at a negative y direction when you guys are calculating this. And just so you know, your radius will always match whatever your y is or whatever your x is. It's always going to be, if it's a 4, your radius is a 4. If it's a 1, your radius is a 1. It's always going to be the same direction because, or same amount, because this unit circle, if whatever that measure is, it's the radius is the same length, right? Okay, with that being said, here's one strategy to handle it. If you guys don't like the idea of memorizing that cosine was x over r, sine was y over r, like that's pretty confusing unless you want to just generate it. What I do is I generate essentially a fake triangle. And when it's a fake triangle because one of the sides has a measure, so a side will have a measure of 0. Well, if I have something that's a measure of 0, it's impossible to draw that triangle. That's why it's fake. But let's just say this. Let's pretend I rotated 360 degrees, or let's say I'm asking for the cosine of 0 even, okay? So if I want the cosine of a 0 degree, okay? I try to draw my triangle and there's no triangle. It's just a line, correct? But if I were to draw a triangle here in quadrant 1 from whatever theta is, which is 0 in this case, and notice how I'm at 1, 0, okay? My x direction is 1, and what's my y direction?
0.
0. That's my y. My x was 1 and my y was 0. And then what's the radius always going to match?
The x.
Whatever this point is, right? Now I have a triangle to do SOHCAHTOA with.
So it's just
So you can draw a fake triangle, okay? So let me try some of these a few times. So for instance, cosine of 0 was what? Cosine of 0 was, this is my fake triangle for 0.
0 or 1? Or 1 over
1 over 1.
So it's just one.
Yeah, 1. Okay? And if you guys try these on your calculator, you'll get those answers, okay? All right, let's try it. Let's see what 90 gives us. So 90 would rotate me initial side, would rotate me here. So again, I don't have a triangle. So if I go over here and draw my fake triangle, and I'm going to pretend theta is right here, the coordinate I'm going through is going to be 0, 1, right? We're going to use ones for easy numbers. Let's draw our fake. So to get to that terminal side, I went in the x direction how far?
0.
0. Okay? So from my vertex, I consider the x direction 0. I'm still at the vertex, correct? But my y direction is 1, and my radius is always going to match whatever length I have. So if these were 4, it would be 4 and 4, 3 and 3, okay? So my radius will be a 1. And now, because this is the radius of my unit circle, right? So that's why your radius will match that. Now I can do SOHCAHTOA. Okay? So what's cosine of 90? Go from this little reference angle. What's cosine of it? 0 over 1. So we just get to say 0. So what if it's 1 over 0? Then what do we say? It's undefined. And we are going to have some undefined measures with quadrangles. Let's try pi. So pi is 180 degrees as well. So pi would drop us right here, and there's pi. And you can draw your fake triangle here. You can also draw it off to the side. So like I usually probably draw my fake triangle on here just because it's easier. But you can also just be like, okay, here's my fake triangle. Okay? So the coordinate I'm supposedly going to be going through, or the point, I guess, before I drew my fake triangle was at -1, 0, right? Wasn't this coordinate -1, 0? Okay, so let's draw our fake triangle. In the x direction, I get to say -1. In the y direction, I didn't go anywhere, so I'm at 0. And my radius is always 1. So because I'm in the negative x direction, you need to remember to say that it's negative. And then let's do SOHCAHTOA from that. So what's the cosine of that? -1 over 1, which is just -1. Okay, we're back to 270. We didn't do that one before, so let's do the tangent of it just for more practice. So what is the tangent of 270? Talk and turn and talk, and let's see if you can set it up with somebody. So set up your fake triangle. 270 is down here at 0, -1, your side going through it. Hurry and see what you guys would get.
Is it always 0, 1 adjacent?
When we're setting up ourselves, yes.
Okay.
Randomly, we will say, hey, your terminal side goes through 0, -4. And then you would make your radius of 4, and then you guys would use numbers if we give you the point that it's going to go through. But when you're generating it yourself, just use the basics, which is 1. Kind of like our 30, 60, 90s, we use the basics, 1, 3, and 2. Okay, what did we get?
Undefined.
Undefined, talk me through it.
What else?
So if I draw my fake triangle, how far did I go in the x direction?
-1.
X direction.
Oh, x direction. 0.
0 in the x direction.
-1.
-1 in the y direction. Radius is always positive. Tangent of it, you guys said is, or again, you guys don't have to do the fake triangle. Tangents was opposite over hypotenuse, which was y's over x's. So you guys could have also looked at this and said, hey, my y over my x is -1 over 0.
Oh, that's so easy.
If you prefer that, it hasn't been easy to some kids. If you prefer it, do it. Because when you guys are dealing with your unit circles, your opposite has always been your y. Your adjacent has always been your x. And then your radius is always going to match whatever those values are. And so if you would, you can just take these and do the ratio yourself if you know it. So if you knew that if you know that tangent's opposite, so tangent of theta is y over x, then yes, you can literally take -1 over 0 and skip the fake triangle. The fake triangle's for the visual people. And I have done it both ways, and I found visual people need this big triangle. So,
I like the triangle.
empty set. Tripp loves the triangle. Other people are like, well, I know it's y over r.
Well, I don't hate the triangle, I just think that both ways are good enough.
Good.
Yeah, that-
Okay,
that's easy.
quadrantal angles are a little tricky. I only make you do it a couple times. It's actually a low priority on our priority list. So it is not something that I am stressed about. Here's the final thing. We already practiced this the other day.
Oh,
So this is gonna go really well for you guys. But now we know the unit circle better. We didn't know the unit circle before. Before, I didn't give you any negatives because of the unit circle. We always had them positives.
yeah, the negative's just like where to place it on the.
Correct.
Gotcha.
Yep. I do have one little caveat, one little thing to switch though. Your calculator will only push out certain degrees, even though it could be 2 different quadrants. Okay? Sine inverse and tangent inverse has domain restrictions. They will only push out negative 90 to 90 degrees. So even though something that drops me in quadrant 4 could be above 270, you're actually going to give us the negative answer because it's restricted to negative 90 to 90 degrees. And we'll talk about that in one moment. Cosine is interesting too. Cosine is technically defined in quadrant 1 and 2 only. So they will give you degrees between 0 and 180. It'll never push out like the other angles. So your calculator answer will give you different answers. So none of your answers would result in something that drops you into that quadrant. And let me tell you, so, because here's the tricky part, is I don't want you to give me 2 answers. So I'll show you how this works. So let's set this up. And this might be on the non-calculator side, so you do need to know how to do it. First of all, when I say all students take calculus, sine of an angle is going to give us a negative 1 over 2 is what this is stating, right? And we want to know what angle gave me a negative 1 over 2. Correct? Isn't that what inverses are? Is finding what angle? So these are finding angles anytime we're using sine inverse. So sine of some angle theta gave me negative 1 over 2. So which 2 quadrants will sine end up being negative in?
Quadrant 3 and.
Good. And I only want one answer though. So I could have this be in this quadrant, but I could also have it be in this quadrant because the sine of it being opposite or y over hypotenuse or y over r is negative 1 over 2 or negative 1 over 2. So how do I know which angle to get?
Well, you said
Well,
it's before.
where is sine restricted to?
Just those.
These ones. So I get to count this out. I get to say it's the negative degree. Because your angles will be negative 90 to 90. All of them will on
When you
tangent.
say negative 90 to 90, like, what does that mean?
So like it could run from like negative 45,
Okay,
you know what I'm
okay,
saying?
okay, yeah,
Or
gotcha.
here, it'll never be bigger than 90.
Okay. So it'll stay in like those two areas?
Yeah.
Okay.
So can you guys pick out which triangle that is, which special this is? Without a calculator.
60.
It's across from the negative 1. I'll help you out. It's a 60, 90. What's across from the 1, the small sling?
30.
Negative 39. Someone test it. Will you guys try that in your calculator and make sure it's in degree mode?
That makes sense.
And if you guys ever plug in like cosine of pi halves, it has to be switched to radian mode. So anyway, would you guys make sure it's in degree mode and someone test it? What's sine inverse of negative 1 over 2? Yeah. Do sine inverse of positive 1 over 2. Positive 30. Does that make sense?
Yeah.
Okay, let's try this one. So this is the same thing as saying cosine of some angle gave me a positive root 3 over 2. So really quick, what quadrant, using the all students take calculus, which 2 quadrants could this one fall within for a cosine to be positive root 3 over 2?
1 and 2. Wait,
Just
wait, actually, wait.
1 and 4.
1 and 4.
Okay? Now, yes, cosine only runs 0 to 180, meaning it won't push out a negative answer. So which one do I not have to count?
The fourth.
I don't have to count it. So even though cosine can be positive here and here, I'm not gonna give that answer, I'm gonna give this answer.
Cause I'm like, it's that one.
Yeah, cause I only wanna give any degrees from 0 to 180, cause that's how cosines, they're restricted. If you guys try it, you'll get like a domain error if you ever try. Like if I ever ask you guys to do cosine inverse, I don't wanna have to come up with a scenario right now. Okay, so here we go. Whatever theta is, we don't know, and that's what we're trying to find. We want the exact value of this, and we wanna know what angle this is. Where do I put the root 3, and where do I put the 2?
Oh, well, 2's gonna be the hypotenuse.
This is the hypotenuse or the r, and root 3 was our
X.
adjacent or the x, right?
Okay.
So adjacent is root 3, hypotenuse is the 2, so this is a 30, 60, 90. What's the answer to this? What's across from the 1? We just did it.
Oh, wait.
We're getting the angles.
Is it 30?
Remember, if you're using inverses, your answer is an angle.
30?
30 degrees. Perfect. If you're ever using inverses, your answer is an angle. Cool? I want to jump to this one. If I have time, I'll do that one. Okay? Sine, inverse. Oh, we'll have time. Let's do both these. So let's set up this tangent one, because we have to do every quadrant, right? Or every trig function. So which quadrants were tangents negative? All students take calculus. Which ones were tangents negative?
The first
Sine and
quadrant
cosine.
and
I don't know.
wait.
What are you asking? I'm so confused.
Sorry, so all students take calculus. Tangents are positive here, so since my ratio is negative, it could fall
Yeah.
here,
So that's right. Sine
or
and
here.
cosine.
correct?
Dude, you're good.
Oh, you said sine cosine. I see what you mean. Those are the positive quadrants, yes. So it can fall here or here. Now, based on my restriction, where are tangents degrees allowed to be within? Tangents are allowed to be within what?
Oh, the fourth one.
Negative 90 to,
90.
so which one do I count out?
That one.
That one. Make sense?
You know what I'm talking
This is on a non-calculator side, so you have to know how to do it. Okay, let's set up and decide what angle gave me that. So tangent was, we're going to put a 1 under that, okay? Since tangents were opposite over adjacent, or y over x, I get to put a negative 1 on the y, and I get to put a 1 on the x. And this, if I do Pythagorean theorem, is root 2, so what is this angle?
45.
More specific? Negative. You guys are awesome. Here's the tricky part. Have we ever gotten a 0 when we've been doing ratios? Not until we did the quadrantal angles. So this must be a quadrantal one. So this is where it's going to get tricky. Okay? I'm curious how far you can go without my help. So I'm going to put a 1 under that, and I want you to take a moment and tell me which quadrantal angle this one is. Try it yourself for a second. So sine is what over what? So we can essentially say sine of some angle gave me a 0 over 1. Let's place those where you think they go, and let's decide. As soon as someone has it, raise your hand. I'm curious what you got. Has anybody got anywhere with this one? This one's really difficult. Those of you who are memorizing the y's and the r's, sine was opposite or y over r, correct? Or start by drawing a fake triangle, even in quadrant 1, even if it's wrong, okay? I do know the sine of whatever theta is 0 over 1, and that means this is 1. So give me the coordinate that my terminal side is going through. Or this one I could have realized that my y was a 0, my radius was a 1, so my x has to be a, or I could have realized my x was a 1, my y was a 0. What coordinate is this? Or where are we at? 0 degree rotation. Now, could have I said 360? Yes, that's in the right spot. However, what is sine restricted to? What degrees?
Negative 90 to 90.
Negative 90 to 90. So I've had students who argue, but 360 falls in the same spot. I'm like, you're right, it is a coterminal type answer, but your calculator will only push out the restricted domain.
Can we see any of these?
The quadrantal angles, you'll see like once or
Like
twice.
one like this, with a 0. Or
You
like-
could, yeah, you could see some quadrantal angles. I am potentially, we've been really nice on the test, however, so if we do a quadrantal one, it'll probably be an extra credit. Yeah. All right, you guys were extremely